Good morning. So last three topics of this chapter are: number one is anomalous behavior of second period elements, then diagonal relationship, and metallic and non-metallic character. First we will do the anomalous behavior. Like the elements of the second period, they show some different behavior than rest of the element present in that respective group. For example, as second period elements, mainly P blocks, like if we start with beryllium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So these elements, they show different behavior than the rest of the elements present in their respective groups. Like in boron, we know that we have aluminium, gallium, indium, and thallium. Carbon, we have a silicon, germanium, tin, and lead. Nitrogen, we have a phosphorus, arsenic, antimony, and bismuth. Oxygen, we have a sulfur, selenium, trillium, and polonium. And chlorine, bromine, iodine, and astatine. First we will see how the properties are different, how they behave different, then we will find the reason. Like in case of say nitrogen family, nitrogen can form NCl3. NCl3 exists, but NCl5 does not. Rather, PCl5 exists. That is the different behavior of nitrogen and phosphorus. Nitrogen cannot extend its valency beyond 3. नाइट्रोजन की वैलेंसी 3 से ज्यादा एक्सटेंड नहीं कर सकता वो. NCl3 होता है, NCl5 नहीं होगा. It cannot form 5 bonds, but phosphorus can form 5 bonds. It can exist as PCl3 as well as PCl5. इसके जो है दोनों exist करते हैं. Like one more example. See, oxygen, sulfur belong to oxygen family. Oxygen will react with hydrogen hydrides from a water, and sulfur will react with hydrogen from H2S. This is the liquid, we know, but H2 is a gas. There is a difference. So it means that first element of each group showed some different behavior than rest of the element. As you can see in boron also, B3 positive does not exist, but AlCl3 positive exists. CCl4 carbon family, take its halide, and SiCl4. Can we write like this? These are the halide. CCl4, SiCl4, both are covalent. CCl4 hydrolysis cannot be done, cannot be hydrolyzed, can easily hydrolyze. That's different. Okay. So why this behavior is different? There are some specific reasons. By taking reasons, we can explain again the behavior. First is due to their small size. Second is high ionization energy. Third is absence of vacant d orbital. These three reasons are there. Like हमने किया था कि that NCl5 does not exist, but PCl5 exists. Reason: phosphorus has vacant d orbital, so it can extend its valency beyond 3. Nitrogen do not have vacant d orbital. उसमें d orbital है ही नहीं. Let's write the configuration. Nitrogen 7, 1s2, 2s2, 2p3. There is no 2d. Phosphorus 1s2, 2s2, 2p6, 3s2, 3p3, 3d0. So d is there, d exists, but 3d exists, but 2d does not exist. So this is the most important point by which these elements, they show some different behavior than the rest of the elements. Okay. And similarly, some electronegativity is also like high ionization energy. You will also write here high electronegativity. By this point, we can explain why water is liquid and H2S is gas. Because in water there is a HO bond and hydrogen bond is formed. That we will discuss in the next chapter how the hydrogen bond are formed. Okay. Ionization energy B3 positive does not exist. ये बोला था हमने B3 positive does not, because high ionization energy does not exist. नहीं होता. Because sum of the first three ionization energy is very high in boron. That's why, because small size, as ionization energy is high as compared to helium, so it does not exist. So this is about the anomalous behavior of cyclic elements. Next is the next topic is diagonal relationship. So you have to concentrate on the points why the elements of second period show different behavior than the rest of the element present in their respective group. Okay. Diagonal relationship. As we know in the periodic table, so this is the periodic table. When we move in this side, size decrease. When we move in this side, size increase. This is the periodic property. Not even size. When you move in this side, you can write it. Ionization energy increase. When you move this side, ionization energy decrease. When you move this side, electronegativity increase. When you move this side, electronegativity decrease. What happened if we move in this direction? They become same, almost same. So when we move diagonally in the periodic table, the elements of second period show diagonal relationship with element of third period, diagonally placed, which are diagonally placed in the periodic table, like lithium beryllium, boron, carbon, nitrogen. This is second period element. Third period elements are say sodium, magnesium, aluminium, silicon, phosphorus. So when we move from lithium to beryllium, size decrease. When you move from lithium to sodium, size increase. Okay, and when you move to this side, size remain almost same. So there is a diagonal relationship between lithium and magnesium, beryllium and aluminium, boron and silicon, like this. So when these elements, they like lithium and magnesium, they are diagonally related to each other. They have almost same size. If they have a same size, then they have the same properties. Most of the properties of lithium and magnesium are same. That you can read from the book, like one list is there, you just simply read it. Don't need to cram. So like beryllium and aluminium. Beryllium and aluminium are diagonally placed, it means their size. If the size is, because all the properties like ionization energy, electron activity, electron affinity, all depends upon the size. If the size is almost same, then all the properties are almost same, and then the properties of the elements, they resemble with each other. So elements of the third period resemble and all in properties with the element present in the second period, which are diagonally placed, and this is called the diagonal relationship. This is called diagonal relationship. Third is metallic and non-metallic. Metallic means tendency to lose electron. One or more than one. Element which we call as a metal, they are electropositive in nature. So when we move in the periodic table, say generally हमने 10th में भी पढ़ा होगा, metallic character decreases from left to right and metallic character increases from top to bottom. Non-metallic character, that increases from left to right, opposite. Non-metallic character decreases from top to bottom. In the periodic table, if you see, this is again the periodic table. In the periodic table, in the left hand side, these are the more active metals are there. Here we have more active metals, and on the right hand side you have less active metals. More active means they can lose electron easily. So here you will get reducing agents, tendency to lose electron. And here you get oxidizing agent. Okay. Now, see in periodic table, nuclear charge. That increases nuclear charge that increases when you move from left to right. This is for left to right. Nuclear charge increases, we know. Shielding. That also increases. But shielding, okay, not this is from top to bottom. Okay, top to bottom in group. Nuclear charge increase because atomic number बढ़ेगा, shielding भी increase होगी. But shielding means shielding का fact है जो dominating होता है. So tendency to make positive ion. So as a result, tendency to make positive ion that increases. Reducing power. That increases because this tendency to lose electron is directly related to reducing power. And metallic nature. That increases. So when we move from top to bottom, you can see like nuclear charge increase, shielding also increase. बट शील्डिंग मीन्स शील्डिंग का इफेक्ट जो वो डोमिनेट करता है, इसकी वजह से साइज बढ़ जाता है. साइज बढ़ेगा तो टेंडेंसी टू मेक पॉजिटिव आयन इंक्रीज, रिड्यूसिंग पावर भी इंक्रीज और मेटालिक कैरेक्टर भी वो इंक्रीज. लेफ्ट टू राइट देखें तो न्यूक्लियर चार्ज that increases. This is for left to right. Nuclear charge increase. Shielding. Also increase. But nuclear charge means here because electrons are adding to same shell. So nuclear charge wins. Then tendency to form positive ion. Tendency to form positive ion. That decreases. Reducing power. And metallic nature. Reducing power decreases. And metallic character also decreases. So this is all about the metallic and non-metallic character of the periodic table. So this ends the chapter. So read carefully the full chapter from NCERT. NCERT की बुक में से एक एक लाइन इसकी पढ़ो. कोई भी दिक्कत आती है उसमें, कोई भी प्रॉब्लम है, just mention in the comment box. Next, we will start the chemical bonding and molecular structure, the next chapter.